Okay, so welcome to still in Unit 3. Eventually we'll get done. We are going to look at the characteristics of functions, and hopefully I can get this all in one video because I really don't want for this to drag on. But the characteristics of the function are the key features of your function, so sometimes it may say like to describe the key features of your graph. So that's the same thing as the characteristics. And usually we do this by looking at a graph, but you don't have to. You can look at an equation or even a description or a word problem. Interval notation was something that was new to you guys this year, and what happens in interval notation is we write the answers using either parentheses or brackets. So what happens is that we're going to use the parentheses if the value is not included and always with infinity. And then the brackets are used when the value is included. So basically what we're talking about is whether the graph or the function, the line, the parabola, whatever it is that you're graphing, if it actually hits that number, then it's included. We always use parentheses with infinity because that's the idea that it just continues on forever, so we can't really reach an ending point. Interval notation, it looks like an ordered pair, but it's not. And what we do is we write the smallest, largest. So it does look like an ordered pair, but we just know that since we're doing interval notation, that we're not talking about ordered pairs right now, and especially if we have something like an infinity sign, that's not going to be part of an ordered pair. All right, for our examples, for the odd numbered problems, we're going to use this. So when we go through the problems, we're going to refer to this to answer the odds, and then we're going to use this situation to answer the evens. That's the best way I could think to set this up. Okay, first thing is the domain, and the domain refers to the x values. So the way we're going to write it is the smallest x, comma, largest x. So looking at this function right here, we are going to put arrows on the ends. These graphs I just actually got off of Googling for a cubic function, but when we look at the x values, what is the smallest x? Now remember the x-axis is going this way, so the smallest x, there's no limit. We can just keep going and going and going. So there's no smallest x, and there is no largest x, because we could just keep going, 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 and going. So for our domain for this one, we would say it is a negative infinity to infinity, and then that always uses parentheses. And again, that's the smallest x, that's the largest x, and we're talking about everything in between. All right, looking at this one, Max kicked his soccer ball. The ball went 26 feet in the air before it hit the ground 40 feet from where he was standing. So I'm just going to do a little sketch here. So here's Max. He has his soccer ball right here. He's going to kick the soccer ball, and it's going to go up in the air, and then it's going to come back down and land. And the ball went 26 feet up in the air, so this is 26 feet. Before it hit the ground, and it probably bounced, but it hit the ground out here, and this was 40 feet from where he started, and we would assume that he's starting basically at 0, 0. Because when he kicked the ball was on the ground, and that was his starting point. So that gives us a little bit of an idea of what this picture would look like. So if we wanted to state the domain, for this situation, the smallest x is 0, because that's where he started, and the largest x is 40 because that's when the ball hit the ground again. So this would be a situation where we would use the brackets. All right, for the range is going to be the same thing, but this time we're going to talk about the y values. Again, we always write it smallest to largest. So the smallest y with the largest y. So looking at this, the smallest y, this is just going to continue forever, and that's going to continue forever. So the smallest y is going to be negative infinity, and the largest y is going to be infinity. For this example, we, again, are assuming that Max and the ball are starting at the origin. So in this case, the smallest y value would be 0, which is ground level. And then we were told that he kicked the ball 26 feet into the air, which would be the highest y. All right, x-intercepts, just intercepts in general. Sorry. This is where the function crosses the y-axis or the x-axis. And if it's an x-intercept, we write it as that number in 0. If it's the y-intercept, it's 0 and that number. So looking at this graph right here, if we do the x-intercepts, there's actually 3 of them. There's one right here at 1, 0. There's one there, and then one there. So for this example, we have x-intercepts at 1, 0, at -1, 0, and at -2, 0. And then our y-intercept is at 0, -2. All right, on this one, the word problem, our x-intercepts are at 0, 0, and at 40, 0, because those are going to be the places where the ball was on the ground. And then the y-intercept, there's only one, and that's at 0, 0, and that's when Max started with the ball. All right, next up, we are going to talk about intervals of increasing and decreasing. So from left to right, what we're going to do is tell the direction that the function is going. We always move from left to right, which is smallest to largest. So basically what we're saying is that y is increasing or decreasing when x moves from blank to blank. And what we write as the answer is that. But we are going to write it in interval notation. All right, so identify over what intervals this function is increasing or decreasing. So to go back to our graph, this function right here is increasing up until here. So right here, it's going up. Then, for a little bit of time, it goes down, I'd say to right about there, and then it goes up again. So it's increasing, then it's decreasing, then it's increasing. So I would say this is probably at 1/2, although those go by 2s. Those might have gone by 2s, but it's not labeled, so we'll assume it's a 1. So this is about at 1/2. And then this one, I'd say, is about at -1.5. So it's very obvious that it's decreasing from -1.5 to 1/2. So I'm going to start with that one. So I'm going to say that this function was decreasing from -1.5 until 1/2. So remember, we're talking about the x. So we're saying y is decreasing when x moves from -1.5 to 1/2. All right, now, around that, it was increasing. So if we go back to our graph, it's increasing from forever until it gets to here. So all of these right here, it's getting bigger, 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 bigger. And then right when we get to -1.5, it changes. And then same thing over here. It went down, and then right when it got to somewhere, it's not quite 1/2, but we'll just pretend it's right around 1/2, then it started increasing again. So for our intervals, it went from -infinity to -1.5. Then it changed over and decreased from -1.5 to 1/2. And then it started increasing again, and then increased forever to the right. So we can say that we know this graph is going up until here, then from here to here it's decreasing, and then from there to there it's increasing. And again, it's the y that's increasing or decreasing. This is talking about the x. All right, looking at our soccer situation. So here we are increasing, and then somewhere right along here, then it's going to be decreasing. And we know if these are the x-intercepts that the change in the increase or decrease is going to happen right around 20 feet, because that would be the vertex of our parabola. So from 0 to 20, y is increasing, and then from 20 to 40, y is decreasing. So we would write this as from, and it started at 0 to 20, that was the increase, and then from 20 to 40, which is when it stops, that was a decreasing. All right, so again, we're talking about the x when we write the intervals. All right, intervals when positive or negative, this is talking about when it's above the x-axis or when it's below the x-axis, and really all we're talking about is the y's. So we want to know when the y values are positive, the function is considered positive, and when the y values are negative, the function is considered negative. Now, I think it's pretty easy on this one, because since it's a word problem that involved kicking a ball, this was positive the entire time. So from 0 to 40. So y is positive all the way when x is 0 to 40. All right, this one, let's flip back to our picture. This one had a lot of stuff going on. It's positive, I'm going to do some shading. It's positive, those points are positive y's, and those points are positive y's. But then we had negative y's. Down here, it's negative, and from there to there, it's negative. And what's different, or when it changes, is when it hits the x-axis. So at our x-intercepts, we had change. So we had 2 places when it was negative and 2 when it was positive. So it was negative from negative infinity until negative 2. And then it was below, again, from negative 1 to positive 1. So from negative 1 to positive 1. Then our function was positive, which meant the y's were positive, from negative 2 to negative 1, and then from 1 to infinity. So again, we're just talking about the x values are what we're writing when the function is positive or negative. All right, extrema, that's our maximum or minimum point. It's also the vertex in most of our situations, and it is an ordered pair. So when we look back at our curve, is there a highest or lowest point? And the answer is no. When we look at this one, is there a highest or lowest? Yes, there's a highest, and it happened at the point 20, 26. So for this one, we had none, and for this one, it was at the point 20, 26, and it was a maximum. All right, I'm going to quickly get end behavior in here. This is talking about what's happening at the graphs, like at the ends of the graph. So if we were to follow the arrows, where are they going? All right, this is the right side because this is saying x is positive. This is the left side because it's saying that x is negative. So on the right side of the graph, our right arrow is going, our right arrow is going up. And it's going to continue to go up forever. So that tells me infinity. This one down here is going to go down, which tells me that's negative infinity. So the right side is going to positive infinity, the left side is going to negative infinity. So the right side is going to positive infinity, the left side is going to negative infinity. All right, on this one, both of them are going to 0, and then they're stopping. So if we were to fill this in, they are both going to 0. And then that's it. And a lot of times this actually doesn't even apply to what we're doing because we don't even have any values of x. So it would be okay. That one wouldn't be a reasonable question because there aren't arrows on the end. All right, that takes care of 3D. So you can pick up your practice set and get started.